A bungee jumper jumps off a bridge which is 200 meters above the water, and the jumper weighs 725 newtons. If the jumper falls to within 75 meters of the water, how much work is done by the bungee cord, ignoring air resistance? Our two forces acting on the jumper are tension and gravity. Y1, where he starts, is 200 meters, and he falls to within 75 meters of the water, which is our Y2. He starts with zero kinetic energy and ends with zero kinetic energy, so the change in kinetic energy is zero. So if the kinetic energy is zero, then the total work done should also be zero. So that's the work done by gravity plus the work done by the cord should equal zero. When we're close to the surface of the earth, we use mass times the displacement of y, and that's how we're going to find the work done by gravity. Gravity should also be negative, so we take the weight of the jumper, which was 725 newtons, and we make it negative. And then our change in y is just y2 minus y1, which was over here, so 75 meters minus 200 meters equals negative 125 meters. We take our formula and we plug in our numbers, so our mass is negative 725 newtons times our displacement in y, which is negative 125 meters, and you get a positive 91 kilojoules. The total work should be equal to the work done by gravity plus the work done by the cord. We already know the work done by gravity, but we want to know the work done by the cord, so we just solve for the work done by the cord, and we get the total work minus the work done by gravity. So we plug in our numbers, and we know the total work should be equal to 0, and then we have our answer from up here, the work done by gravity, so minus 91 kilojoules, and we get negative 91 kilojoules, which we know is right because the work done by the cord should be equal to but opposite of the work done by gravity.